Everyone, it's time to go over the homework for the week. I'm hoping to get this done in a half an hour. If I'm going too fast, you can always make your YouTube go slower, or you can just rewind and watch it again and again until you get it. So here we go. There's a lot of problems today. I'm not going to do the ones that repeat, so maybe just one or two. But mostly if I do that type of problem, I won't do that type again just to save time because there are a lot of problems, as I was saying. So you can see here how many problems we have. Look at all those problems. Yikes! It's like practically doing the whole lessons. So here we go. Let's see what we can do. So the first one is lesson 65. Let's hit all our lesson 65 problems. Number 3, which is a mixture problem. It says the solution came up to the 500 milliliter mark on the beaker. If the solution was 84% alcohol, how much alcohol should be evaporated so that what is left would be only 80% alcohol? Bucket problems. You should learn to love bucket problems because they're so straightforward for the most part. We are evaporating, so we're going to subtract. We're starting out, you put the milliliters or whatever the measure is in the bucket. So it's 500 milliliters at 84%. You don't need the percent sign because we're moving our decimal over on all of them. We want to know how much is going to be evaporated. Now this is the tricky part. This is 84% alcohol, right? So how much alcohol is in alcohol? It's 100%, so you're going to use 100. If you're going to be evaporating water, that would be 0%. Okay, and then what's left in the bucket, if we take out X milliliters, we have 500 minus X, and we want it to be 80%. This is a one variable problem, so we only need one equation. So you're just going to multiply the percent times what's in the bucket. So it's going to be 84 times 500 minus 100 times X, and then it's going to be 80 times 500 minus X. Distribute that through. I'll finish this one for you. 42,000 minus 100X equals 40,000 minus 80X. Oops, this should have been an 80. Oops, got that there. So we're going to get speed math. We're going to get 2,000 equals 20X, and we're going to get X equals 100 milliliter. That's it. So bucket problem with one variable. Okay, problem number 2, which isn't really number 2. It's lesson 65, number 5. This one says 4% of the phosgene combined with, the ignorant exceeded the, let me make sure I'm doing the right problem. Never mind, it's number 5. 4% of the phosgene combined with the other chemicals. If 1,900 kilograms did not combine, how much did combine? I did my little circle thing. Here we go. We have 4% over here. I know I didn't do that to scale. That means there's going to be 96% over here. This is the combined, and this is did not combine, so I called it that. We know that 1,920 did not combine, so I put it in the not combined section. We need to figure out the total. So 96% of the total equaled the not combiners. So I'm going to make that into a decimal, 0.96. X equals the not combiners, and that's going to tell us what the total is. Sometimes I like to use a T there for total. We divide both sides by 0.96 and we get 2,000. That's the total. So let's just do total. That's the total. And we can figure out the combiners by subtracting the not combiners from the total, and we're going to end up with 80 kilograms did not combine. Number 5, that was a circle problem. Alrighty, number 9. Lesson 65, number 9. So it looks like this. We have a couple questions on this one, but I'm going to do 2 of these. So the first thing you want to do is you want to start in the denominator of the denominator, and we're just going to bring that X along for the ride. So we are going to find a common denominator of the denominator, which is C. So we're going to need to multiply the A by a C plus the B. And then we take the second fraction. It's a complex fraction. We're dividing, so we're going to flip and multiply. So this is a flip-de-doo. So we're going to flip this over. It's AC plus B. Again, common denominator is AC plus B. This one we need to multiply by AC plus B. I'm going to distribute that right on through. So we get ACX plus BX plus C, and that is your final answer. I really like these problems. I hope you do too. All right, we're jumping around. We're jumping the whole way to 17. Hopefully I didn't miss anybody's problem. Let's see. We're going the whole way to 17. Yep, and oops, 15. Chad snuck one in at the last minute. All right, let's look at 15. 15, lesson 65, 15. If it's one that I do later, oh, okay, Chad. Yep, now I'm going to need my calculator. I didn't do this one ahead of time. So lesson 65, number 15, we add 20 at 45 degrees plus 10 at 210 degrees. All right, so this is in polar notation. We want to find x and y and put it in rectangular coordinates. So if you graph these, it's going to look like 20 at 45 degrees like this, right? So this is going to be 20, this is going to be 45 degrees. We need to find x and we need to find y. So and this one's going to be 210 degrees, which is going to be down here because that would be 180 plus more, giving you 210. And this is going to be 10 length, and the angle, we're just going to use the 210 degrees. We just know where it's at. We know the x and y on this one are both going to be negative. The x and y on this one are both going to be positive. I like to do it like this because it's easier. I'm actually not going to calculate the whole thing. I'm just going to set it up for you. You can put it in your calculator. So you would do for x, we're going to use cosine. So we say 20 cosine of 45 degrees plus this one over here. So it's going to be 10 cosine of 210 degrees. Then we do our y. So we say y equals 20 sine of 45 degrees plus 10 sine of 45 degrees. All you do is you're going to pop these in your calculator and out will come a decimal answer, and these should be really easy for you. I've kind of eliminated a lot of the work when you do it this way, so hopefully that helps, Chad. All right, we have number 17. Lesson 65, number 17. Solve. I'm doing one of these even though I think someone asked for these every lesson. So pay attention on the one. If you're missing them on another lesson, it's probably because you're making a careless mistake, and I'll try to help you see where you might have made the careless mistake on other problems as well. Okay, so we have a system of linear equation. We have two variables, so we need two equations. We like to get rid of fractions and decimals. If you want to keep them in and try, go ahead, but it's going to be like a nightmare. The common denominator here is 42. So I'm going to multiply. I'm going to distribute the 42 through. Make sure you get this side as well. That could be a common problem. So 7 goes into 42 6 times. 6 times 2 is 12x. 6 goes into 42 7 times. 7 times 1 is 7. And then we get our 42. Don't forget to do that. Now I'm just going to move the decimal point over. We have to move it over 2 places so that they're all whole numbers. But whatever you do to one, you have to do to all of them. So we are going to end up with 30x. Check this out. It's going to be plus 7y equals 84. Now we have no decimals, no fractions. We can eliminate. This is a simple elimination because the y's eliminate right away. So we get 42x equals 126. And we divide both sides by 42, and we get x equals 3. Plug that back in. This is not an easy feat, but you can use a calculator. You can plug it back in wherever you want. You could put it here, you could put it here, you could put it here. And when you do that, you get y equals negative 6/7. All right, so we did that one. You could write it as an ordered pair, 3, negative 6/7. When you have a system of linear equations, write it as an ordered pair. All right, next one, number 19. We're still in the first lesson, 65, number 19. All right, solve by completing the square. Let me look at it. It looks like this, 2x squared minus 4 equals negative 5x. You guys have asked for these through multiple lessons, so if this is a problem that you don't know how to do, this is the only time I'm going to do it, so pay attention. All right, when you're solving by by completing the square, you cannot have a coefficient in front of your x squared term. So you need to divide everything by 2. So I'm going to set it all equal to 0 and divide by 2 all at the same time. So 2x squared divided by 2 is x squared. Let's bring this over. So it's going to be plus 5, but we're going to divide it by 2x. We're going to complete the square, so I'm just going to bring the 4 over at the same time, and I'll just leave it 4 over 2 so you can see what we did. So I just divided everything by 2 and put it in the right place. Now we're going to add a replacement guy over there. Now how do you complete the square? You take the coefficient of the x squared term, you divide it by 2. When you're talking fractions, dividing by 2 is the same as multiplying by 1/2. So we do that, and we're going to get 5 over 4, which is 25 over 16 when you square it. So we put it on both sides, and we get x plus 5 over 4 squared equals 16 is your common denominator to this guy. So it's going to be 57 over 16. And then we're going to take the plus or minus square root of both sides. So we get x plus 5/4. When you take the square root of this, the square and the square root, we bring everything out. And we're going to get plus or minus the square root of 57. And then it's going to be the square root of 16, which is 4. And then finally, we're just going to subtract the 5/4. So we get 5/4, negative 5/4, plus or minus the square root of 57 over 4. So hopefully, like, that helps you with all the other ones that are coming up. And the last one, you guys, the blob problems. Every time I have to do the blob problems. All right, let's try to get it. I'm not going to do, someone asked for some in the future lessons, so I'm just going to do this one blob problem. So when you're doing the blobs, you guys saw how you can use the blob problems to predict the growth of dogs. It's a very useful tool. So what I did was I looked on the grid and I found 2 places that crossed the grid line, right? As close as I could get. They weren't perfect. So I got this point down here. This point was 1650. And this point way, way, way at the top of the graph was at 2100 and 500. All right, so those are the 2 points. So we have to find the slope of the line, and then we have to figure out where the line's going to cross the y-axis because it doesn't show up on the chart. So this is kind of where, well, that's bad, but hey, it was a little off anyway. All right, so we're going to find the slope. So you do the slope. You subtract the y-coordinates. Let's see. Something was wrong in what I wrote. This is 500, not 5. Okay, so here we go. Subtract the y-coordinates. 500 minus 50 over 2100, the x-coordinates. So you get your slope is, when you put that in your calculator, just put it, get it. You're going to get 450 over 500. Put it in your calculator, get the slope is 0.9. All right, when we're writing our equation of a line, the y-coordinate was R for, or P for potassium, and the x-coordinate was R for grams. So I'm going to use those letters instead of y and x. So we're going to get P equals, our slope is 0.9, R, and we don't know what B is yet. So in order to find B, we're going to take one of the points, doesn't matter which one, I'm going to use this one, put it in. This is your x coordinate is your R, your y coordinate is your P. All right, so P, so you get 50 equals 0.9 times 1600 plus B, multiply that together, subtract it, and you get B equals negative 1,390. All right, so you have your B, you got your M. Now we just put it in this equation. We get P equals 0.9, we leave the R in, and negative minus 1,390. Slightly off from the back of the book, not much. So I know that I was on the right track, so that's what I want you to do. It might not match exactly, but it should be really close. I think it was like 0.89. So for the slope, which threw mine off a little bit. All right, we are done with the first lesson. Yay. So let's go on to lesson 66. I told you it was going to be speed homework. All right, 66. So here we go. Lesson 66, number 2. That one said the initial pressure and volume were this, and this. What was the temperature if the pressure was increased to 800 and the volume was increased to 60? Okay, there's a little formula. If this is on the test, I will give you the formula, P1 V1 over T1. It's easy to memorize though. P2 V2 just kind of comes right out. P2. So you're going to fill everything in. The initial pressure was 400. The initial volume was 6. The initial temperature was 200. Then they said they're going to increase the pressure to 800. They're going to increase the volume pretty significantly to 60. And then we are going to find temperature 2. So what I did here was I just multiplied, actually I took the 200 into 400 and got 2. So we get 12 equals, and this is going to be 4,800 over T2. And then cross multiply, so you get 12 T2 equals 4,800. We're almost there. T2 equals 4,000. And make sure you put your units, it's in kelvins. So yeah, when you have chemistry, you'll learn about all that. Right, number 2, we are on number 8. All right, number 8. Number 8 is not a word problem. So we're done with word problems for that one for some reason. You guys didn't have many problems with those. X minus 2 minus 2x over x minus 2. Oh, I skipped a step. I factored this. I didn't copy the problem down. So you have to factor your denominators before you find the common denominator. So your common denominator is x plus 2 times x minus 2. This one matches exactly, so you can just put the 4. This one, if you compare, needs an x plus 2. So make sure this negative sign gets distributed through both of them. That could be where you made your mistake. So negative 2x squared minus 4x. You can put these in order if you would like, but it doesn't really matter because we can't factor it. So anyway, to be more exact, 2x squared minus 4x plus 4 all over x minus 2, x plus 2. Okay, number 12 was a biggie. You have to think on number 12. It's just not like a problem that we do all the time. So it's a circle in a circle. So we have our circle, and in our circle we have another circle, kind of like this. And then they have a line going down through the center of the circle and through the center of the baby circle. So what the problem says is you want to find the area outside of the little circle. The only thing they give you is that the radius is r. So the radius of the little circle is r. And they tell us that the larger circle has a diameter of 6r. So this whole thing's 6r. So if we're talking about the big circle, there would be 3 radiuses up here and 3 here. So this is like 1/3. Yeah, that makes sense. It looks pretty good. Okay, so what we're going to do is we're going to find the area of the big circle minus the area of the little circle. So the area of the big circle is area equals pi. The radius of the big circle was 3r squared minus the area of the little circle, which is pi, and its radius is just r squared. So we're going to get 9r squared. So 9 pi r squared for that one minus pi r squared. You guys are going to be like, this was so easy. 8 pi r squared. And you have to put your units, of course. Meters squared. Number 12 wasn't horrible. Just it's kind of abstract because you're dealing in r's and not in numbers. Number 14. Okay, I said I wasn't going to repeat problems, but this one's ever so slightly different, so I thought I should do it. So this one has a denominator in the first fraction. So you're going to find the common denominator of the denominator, which is x. We're down here, dealing with this right here. And this one is missing an x in the denominator, so it's going to be x squared plus 1. Then we do our good old flippy-de-doo. So m over x plus x over x squared plus 1. Then we have to find the common denominator of those denominators, which is x times x squared plus 1. This one needs an x squared plus 1, and this one needs an x. So distribute all that through, so you get mx squared plus m plus x squared. And that is it. Yeah. Okay, let's go on to the next one. 14, we are on to 16. Hey, I told you I feel like I'm doing all the problems here. 16, oh, I like this one. 4i minus 2, it's just quick. 3 plus 5i. All right, this is a binomial times a binomial, so you use the good old FOIL. You do your first, 12i. You do your outer, which would be plus 20i squared. You do your inner, which is negative 6, and then you do your last, which is negative 10i. Treat the i's just like you would an x. So if you take an I times an I, you get an I squared. Now, I'm going to add all the imaginaries up. This is going to end up being imaginary, and this is that imaginary. So those are the i's. We're going to say this I squared for just a second. So it's going to be plus 4i. Or maybe not. This is going to be 12. You guys are all like, stop, you made a mistake. Okay, so this is 12. 4 times 3 is 12. So 12i minus 10i is 2i. Now I squared equals negative 1. So this is really going to be a negative 20. So we have negative 20 and a negative 6. It's negative 26 minus, or is it, 1 second, plus 2i. There you go. Okay, let's go on to number 18. This is a common problem too, so I'm going to only do this one time, I think. So we're going to write 8r plus 4u in polar form. Now we're going to go into polar form. The polar form has a vector length, and then it has an angle we have to find. So this is the same thing as 8, 4. That's the same thing. It's rectangular coordinates. You can write it right and up, or you can write it 8, 4. So we're going to plot it just so you can see what we're doing. So we have a triangle that's going to be 8 to the right and 4 up. It doesn't have to be exact at all. The whole thing is just to get an idea what quadrant it is in. So this side right here of the triangle is 8. From here to here is 8. This length, these are always going to be positive, is 4. We do the Pythagorean theorem. 8 squared plus 4 squared equals c squared. And we're going to get c squared equals, it must equal, I'm going to have to do that. 64 and 16. Let's just do that. And so we're going to get 80, yeah. So c is going to equal the square root of 80, and that simplifies into 16 times 5, which would be 4 root 5. All right, so that's this part, 4 root 5. All right, Pythagorean theorem for that one. We made a right triangle. We can Pythagorize theorem it. Okay, now we need to find the angle. To do the angle, I think I do another one of these. You're going to use inverse tangent. The inverse operations give you the degree of the angle. So we're going to do opposite over adjacent. So this is opposite over adjacent, which are the two sides that they give you. You pop that in your calculator, and out comes 26.5. I can't read my other number. So it's going to be about 26.5 something. Can't read what I wrote. You take it out 2 decimal, round it to 2 decimal places. So this is your final answer for that one. Okay, 18. We are on, oh, you know what? I have to do C. Didn't do C. So let's pick that one up. Anyone that came in and put answers like at 12, I mean, that's what I told you. I just did it the last minute. So, all right, so we have a triangle problem that looks something like this. This is supposed to be a right angle. Let's see if I can right angle it. Not great, but all right, so we're speeding it up. I'm going to do another one identical to this one. I wish I could just copy and paste it, but I don't think that's a skill I have. Okay, so we have 2 triangles. The one that's given, we really only have one triangle. It's A, B, 7, and then 30 degrees. Now, I told you had to memorize the right triangle when it's a 30, 60, 90. So if this is 30, this is 60, and this is 90. Okay, so we just kind of memorize the model. The one across from the 30 is 1. The one across from the right angle is 2, and the one across from the 60 is the square root of 3. Now there's other ways to do it, but we're going to use similar triangles to do this. So this one and this one, they're both across from the 60, so we're going to do left over right equals left over right. So 7 over the square root of 3. Let's do our A. So left over right, this lines up with the 1. You don't even really need to cross multiply because this is the answer, right? Anything over 1 is just A. So that's that answer. Then we're going to do the same thing. 7 over root 3 equals B over 2. You just have to multiply both sides. Oops, I didn't rationalize. Excuse me. So square root of 3 over 3 is A. You can't leave it in the denominator, so you need to take the square root of 3 times both parts, and you get this. And this one's going to be 14 over root 3 equals B. And again, we need to rationalize. So it's going to be 14 root 3 over 3 by taking the top and bottom by the square root of 3. And those are your two answers. Okay, where did I leave off? We are on, we did 18, 28. If I skip any, it's because they're reruns. 28, I think, anyway. Lesson 66, number 28. Okay, this is an oldie but goodie. 28. So this is free the y. Py, px minus y over m minus c equals k over d. So common d is m. So we have px minus y. What am I doing? The common denominator is md. It's an equation, so we can get rid of the denominators. If it was an expression without an equal sign, you would have to put it all over the denominator. Okay, your common denominator is md. So you're going to multiply every term by md. So this one gets an md, this one gets an md, and this one gets an md. The m's on this one cross out, so you get p dpx, if we put them in alphabetic order, minus dy minus c dm equals the d's cross out equals km. We're solving it for y, which is a little bit easier than a lot of them. We're going to bring everything, let's make this one positive. I did it differently, but let's do dpx minus cdm minus km equals positive dy. Divide everything by d, and that is your final answer. Y equals this stuff right here. So hopefully that was good. Okay, I'm just going to peek back real quick and make sure I didn't miss anything from lesson 66. Okay, and Chad's coming in, 12. I think I determined that 20 was completing the square. It was a rerun. And 22 was the similar triangle one, Chad, that I did. So go back and look at example C for that one. Okay, lesson 67. All right, lesson 67. The first one is number 1, I do believe. Okay, yep. Okay, this is lesson 67, number 1. The number of Danish invaders who were repulsed varied directly as the number of Danes who attacked. If 12,400 attacked and 2,000 were repulsed, how many were attacked if 3,000 were repulsed? Okay, it was a little bit tough figuring out variables for this, but the number of repulsed was varied directly. So this is your K, and directly means let's go on the top as the number who attacked. So I use R and A, repulsed, attacked. Okay, they said that there were 2,000 that were repulsed when 12,400 attacked. We get our constant proportionality, which is weird, it's 0.16. Yep. And then we can rewrite the equation if we want to. R equals 0.16A. Now, they're saying how many were attacked if 3,000 were repulsed? Well, that's why we have letters on there that go with it. So we're going to put in 3,000 for the R for repulsed. And we use our 0.16, and we figure out A. We divide both sides by 0.16, and we get A equals 18,600 were attacked. Was it attacked or attack? who attacked. These are how many attacked. Okay. Number 1 is down. Number 2 is another mixture problem, or number 3 is another mixture problem, which I did because it's a little bit different. So I'm just going to set this one up for you guys. Number 3, it says the original mixture weighed 400 pounds and was 20% fertilizer. How much of another mixture of 80% fertilizer should be added so the result would be 32% fertilizer? So we're adding our buckets. So we put our buckets there. There's 400 in the bucket. How much should we add? Well, now how much is in the bucket? 400 plus X is in the final bucket, right? They tell you the percentages. We got 20, 80, 32. So you just put those under. I think once you get these, guys, they're like one of the most fun problems that you do in this class. So 80, even though they're word problems, which is crazy, right? And you get 32 times 400 plus X. Save time, you guys can solve that. You get X equals 100 pounds. Only one variable, only one answer, only one equation. Okay, number 11. Wow, what a jump. Lesson 67, number 11. Oh, these are hard to write. So RP, TP equals 1062. RT, TT equals 295. Then we have our little baby equations. Well, they're not that baby. TP equals TT minus 2. And then we have RP minus 6 RT. This one's not too bad because they're solved for the variables. So we have a P subscript and another P subscript. So we're going to use the equation. You can pick between the two. But since they're both solved for the P subscript, we're going to use this one. You just simply substitute it back into the one that has the same subscripts. So RP is 6 RT. I just like to put them in the order to distribute. And TP right here is TT minus 2, and that equals 1062. Distribute it through, and this is where the miracle happens. RT, TT minus 12, RT equals 1062. We substitute. TT equals 295. So we just substitute that in there. So 6 times 295 minus 12 RT equals 1062. Multiply this together and subtract it from both sides. And we get 708 equals 12 RT. I subtracted it and subtracted this. And we get RT equals 59. And then I'm going to let you guys go back and find the other parts. So you take your 59 and you put it, we have RT. So we put RT here, we're going to get RP. Then we can put RP in here and get TP. And then we can put TP in here and get TT, and there you go. Okay, 11, we are on 17. I might have skipped a few because they're reruns. So lesson 67, 17. Now, this is a rerun, but I just want to show you a little twist on this one, why you might have missed it. Okay, the problem is we want to put in negative 4r minus 3u. We want to write it in polar form. This is the same as the point negative 4, negative 3. So look, 1, 2, 3, 4. 1, 2, 3. I'm not usually this detailed with this, but look what quadrant it goes in. It's going to be in the third quadrant. So the sides, we're going to go 4. Remember, we make our sides positive even though it's a negative 4. 3. This is a Pythagorean triple. It's a 3, 4, 5. So you don't even need to do the Pythagorean theorem, but if you don't remember, 3, 4, 5 has to be the longest side. You can just put the 5 in. So we're trying to find our vector length, and then we need our angle. So our vector length is 5. To get the angle, which is right here, you would do your inverse tangent is opposite over hypotenuse. And when you pop that in your calculator, you get 36.87. That's the problem, though, is that's this angle. We want the angle that wraps itself the whole way around like this. So we want this angle. So you have to add on to that 180 degrees because that's this part right there. And you get your final answer. When you add that on there, you get 216.87 degrees. That's a 6. All right, number 23 was it 23? Let me just check if it's 23. Yes, we do. No, that's for the last. No, we do have a 23 and then 29. I think 23 was a rerun. Yes, it's a blob problem. I'm not going to do another blob problem. Okay. All right, let's go on to number 29. Now, we've been doing these forever. And these are like super, super important for the SAT. So you have, for 29, you find the equation of a line through -2, 4, and 5, 7. These are just 2 points. The blob problems start like this, where you get 2 points. So I can see why I couldn't do the blob problems if these are a problem. So you find the slope, you subtract your y coordinates, so 7 minus 4. Then you subtract your x coordinates. 5 minus a minus 2. So it'd be 5 plus 2. So we're going to get 3 over 7. That's your slope. Now you need your b. So you go y equals mx plus b. It's our big friend. We pick a point. I tend to pick the positive ones. So this is your x, this is your y. You put that in for x and y, and you put this in for your m. So you get 7 equals 3/7. Yep, there's fractions. Times 5 plus b. So this is 15/7. This would be 49/7. And so your b would end up being 34. So you have your m and your b. You go back to y equals mx plus b, and you replace your m and your b with what m and b are equal to. So you get y equals 3/7 x plus 34. All right, one more lesson. Yay. Okay. Oh, and there's only a few of these. Now, the first one in the next lesson. Let's just go look at this real quick. The last lesson is right down here. I don't know who's entering like the wrong kind of problems. Like here it was evens and someone put odds. I'm just not doing those. Here there's not a lot for this lesson. There's only 4. Yeah, there's only 4. That's pretty good. Okay, let's go do these 4 problems if they're not reruns. So the first one is a scientific notation problem. I didn't really teach you how to use your calculator for this. You can just do it regular, or you can use your calculator, which I did. So this is lesson 68, number 6. So I entered it in. So in your calculator, you get like this, 0.000418. And then you do times 10 caret to the -14. Now, when you do the -14, put parentheses, or else it'll just take it to the -1 power. The deal is you want to put your calculator in scientific notation. If you have this normal plain little calculator that most of you have, at the very top there's a second key, and then you can see it's scientific engineering. You can put it in scientific notation. So I put that in and I got an answer out. And then I did the same thing with the denominator. I said answer. So there's a thing that you can say, it's second answer. So you say answer, so the answer to this comes up. And then you say, so it'll be answer. So you do second. Yeah, trying to go too fast here. So you get second. And then you do answer. And that just takes the answer to this one. I use second answer all the time. And then you say divide, and then you use parentheses. I'm going to not put the blocks around there. Parenthesis, and then you're going to do the bottom one. 501.635 times 10 caret. You don't need the parentheses this time because there's not a negative number. And you push equals, and your answer will come out. And that's all there is to that. It'll come out in scientific notation, everything. So do the same thing for 6b. Just enter it in, make sure your calculator's in scientific notation, and it takes care of all the work for you. If you need help with this in class, I'll show you how to use your calculator for that one. All right, so we had only one more that I was going to do for this one, and that is 68, number 26. Let me just check real quick. 68, was that even one of the ones? Let's just go through each of them. 6, so 22 was one of the fractions and decimal ones, Shannon. 24 was a completing the square. And then 30, what happened to 26? 26 is the one we're going to do. So, and then 30 is the one where you have to find the slope and find the equation that goes through it. So yeah, so let's go do 26 and then we will be done with this video. Okay, this is lesson 68, number 26. Square root. So 3, I didn't know where that 3 was, but it's actually the cube root because I did it both ways. And this one had the right answer. And this is the 7th root. Whatever is on the seat is the bottom of the fraction. So we're going to replace our radicals with parentheses, and what's on the seat is a 7, so it's going to go on the bottom of a fraction. The 3 stays a 3. This is on the seat, so when we write it as a fractional exponent, it goes on the bottom. I did what's inside first because it's really easy, because if this is 1, I just take 3 times 1 plus 1 is 4/3. 3 4/3 times 1/7 to the 1/7 power. So it's going to be 3 to the 4/21. And that's your final answer. So there you go, your homework video for the week. I don't know how long it is yet, but we'll soon find out.